In the Intermolecular Forces lab, you're going to look at the relationship between evaporation and intermolecular forces. So you're going to dip a temperature probe that has filter paper wrapped around it into different solutions, and you're going to let that dry and record the minimum and maximum temperatures. So once you do that, you're going to determine the intermolecular forces that are present in each molecule, and you're going to answer some questions and think about how the intermolecular forces affect your change in temperature for your different substances. So you've got a few different substances that you're going to use, and what we need to look at is the structures of those substances, because your structure is going to determine, or is going to have some influence on what the intermolecular force is. And we also need to look at the molar masses, because that has some effect or some relationship as well. So let's look at the first molecule you're going to use. The first molecule that you're going to use is heptane. So heptane, or the first solution that you're going to use, you can't actually get a molecule of heptane, but you're going to have a solution that is heptane. Heptane has a chemical formula of C7H16. So what you're going to do is you are going to put your temperature probe in there and get your maximum and minimum temperature, as we've already mentioned. But let's look at what the structure of heptane is. So C7 means that we have 7 carbons in a chain. So 1, 2, 3, 4, 5, 6, 7. And then we have the hydrogens connected around it. So write down this structure. You can write it on your report sheet if you can find room, or you can write it on a separate sheet of paper, because you will need this information. So this is the structure of heptane. So go through and add up what is the molar mass of C7H16. And make sure that you record the molar mass on your report sheet. So once you've done that, then we need to determine what intermolecular forces are present in heptane. So our options are London dispersion forces, which we abbreviate LDF, dipole-dipole, or hydrogen bonding. So you're going to tell me what the molar mass is and what the intermolecular forces are that are present in heptane. Let's take a look at our next molecule. We have 1-propanol, and 1-propanol has a molecular formula of C3H7OH. And to give you a little bit of a preview of organic chemistry for those of you that will need that course, we know that this is an alcohol because of the OL ending. That OL ending is how we name alcohols. And the 1 here tells us where the alcohol group is. So when I make my carbon chain, the 1 tells me that the alcohol group, and the alcohol group is this OH here. And that's why we write this separately, and you can also write this as C3H8O. But a lot of times we'll write it this way, C3H7OH, because that gives us a little bit more of what the structure looks like. So we're going to have our OH on the first carbon, and then we're going to have our hydrogens coming off of the rest of the carbons. So this is what 1-propanol looks like. So you're again going to go through and add up the molar mass of 1-propanol. And you're going to add up, or you're going to determine what the intermolecular forces are. Your next molecule is 1-butanol. So again, the OL ending means that we have an alcohol. And this alcohol has a molecular formula of C4H8OH. So we have 4 carbons this time. And then again, since this is 1, that means our OH group comes off of the first carbon. And then we're going to put hydrogens around the rest of the carbons. So that's the structure for 1-butanol. So go through and add up what is the molar mass of C4H8OH. And then you're going to tell me what is the intermolecular force or intermolecular forces that are present in 1-butanol. So our next molecule is 3-pentanol. 3-pentanol has a structure of C5H11OH. So again, OL and that OH, we have an alcohol. So we have 5 carbons. 3 tells us that the OH comes off of the third carbon this time. And then we put the rest of our hydrogens in. So again, I'm going to have you go through and add up what is the molar mass of C5H11OH. And then you're going to tell me what are the intermolecular forces present in C5H11OH. Okay, our next set of 3 ends in ONE. And our next molecule is 3-pentanone. So the ONE ending is because we have a ketone, which means that we have a double bonded oxygen. So the formula of 3-pentone is C5H10O. So we have 5 carbons, and similar to the alcohols, 3, 5, the number tells us where that double bonded oxygen is going to be. So the double bonded oxygen is going to be on our third carbon, and then we're going to fill in the hydrogens. Now we don't need any hydrogens on this third carbon because it's already got 4 bonds around it. So we're going to fill in our hydrogens on the last 2 carbons, and that's 3-pentanone. So just like the others, I'm going to have you go through and add up the molar mass of C5H10O. And then you're going to tell me what the intermolecular forces would be. So let's do our next molecule, which is 2-heptanone. So 2-heptanone has a molecular formula of C7H14O. So we're going to put our carbons in. 1, 2, 3, 4, 5, 6, 7. And then 2 tells us that the double bonded oxygen comes off of the second carbon. And we're just going to fill in our hydrogens here. So once again, I'm going to have you go through and add up the molar mass of C7H14O. And then you're also going to tell me the intermolecular forces that would be present. Our last molecule is 2-butanone. So we have C4H8O is our molecular formula for 2-butanone. So we have 4 carbons, and 2 tells us the double bonded oxygen comes off the carbon. We're going to put our hydrogens in here. Hydrogen. There we go. So all of our hydrogens are in there. And one more time, I'm going to have you add up the molar mass. You're going to add up the molar mass of C4H8O. And then you're going to tell me what the intermolecular forces are. So you have some discussion questions that you need to answer. If you look at number 1 of your discussion questions, it has several liquids there. Part A has 3-pentanone and 3-pentanol, and Part B has 2-butanone and 1-butanol. And what we realize is 3-pentanone and 3-pentanol have nearly the same molar masses, but when you do your delta T values, you will likely find that they have very different delta T values. So thinking about the intermolecular forces present, why are the delta T values so different for 3-pentanone and 3-pentanol, even though they have very similar molar masses? And then you're going to answer the same question for 2-butanone and 1-butanol. For question 2, you're going to tell me which of the alcohols has the strongest intermolecular forces and the weakest. And you're going to explain using the results of your experiment. For number 3, you're going to look at molar mass versus delta T for your 3 alcohols. And the 3 alcohols are the ones that we already mentioned: 1-propanol, 1-butanol, and 3-pentanol. So you're going to look at the trend for molar mass versus delta T for those, and then you're going to predict, well, you're going to calculate first the molar mass of methanol and hexanol, and then based on the trend you see, you're going to predict what you think delta T would be for methanol and hexanol. And then your last question, you need to rank the intermolecular forces from weakest to strongest for each pair there. So make sure that you have read through your lab handout and that you have submitted your purpose and procedure for the Evaporation and Intermolecular Forces lab. And I will see you in lab.